So this is what the Smith chart. Now, what is the role of this Smith chart? Now, in this Smith chart, this is what a complete multiple lines are there and some lower lines are there. So, what is this Smith chart? Now, here, as we know that the microwave engineering is used for the impedance matching is the one way, and there are some other parameters also, VSWR and all these things. So to map and plot on this, so we have to do the impedance matching. And so initially here the reflection coefficient and all these values we can plot. So initially very basic things we will go for this, that is the location of the impedances on the Smith chart. So Smith chart, if you want to plot any impedance on the Smith chart, so what happened? What you have to do? You have to do with uh, the impedance, the plotting of the Smith chart. Now in this Smith chart, suppose you want to locate an impedance. Okay. So the impedance value, suppose again you will say the ZL. Okay. So ZL is the load impedance, or you can say Z1, Z2, Z3. Any impedance you can tell it. Okay. Suppose this is what your impedance. So I'll name this as ZL or Z1. Okay. So any impedance, suppose this is the Z1. So Z1 equals to, you will have impedance equals to Z1 equals to suppose 100 plus J50. The J, this will be the small j. This J represent the imaginary part. Okay. So here this impedance will be there. Now this Z1, we require a reference impedance that is called Z0. So this Z0 is characteristics impedance. So this Z0, we will assume here Z0 equals to 50. Now if your Z0 equals to 50, then we have to calculate the normalized impedance. So Z1, you can say normalize, Z1 normalize is in a simple way. That is your Z1 divided by Z0. So Z1 divided by Z0. So 100 divided by 50, it is 2, and plus 50 by 50, it is 1. So it is J1. J1. Okay. So our interest is this. So this is what my interest, this impedance that I
Sir,
have to
this
plot.
Z0, it will be given in the question, or we have to assume
Yes.
any number depending upon the given
No,
question.
it will be given in general case. The Z0 is almost 50, or sometimes it is 75 ohm. Generally, the Z0, the characteristics impedance is given, and it is most of the cases, whatever the standard instrument or these use, it is 50. So if it is not given, you can assume it as 50. So this
Okay.
you have to locate. Okay, though this is what the point that you have to plot. Now, this is what your uh, question. Now, how to plot this point? Now, we'll come back here on the Smith chart. Now, on the Smith chart, if you will come for this horizontal line, so horizontal line here, it is a you can say here it is a 0, 0. This is point 1. This is point 2, point 3, point 4, point 5, point 6, point 7, point 8, point 9, and 1. So this 1, it is the center of Smith chart. Okay. So it is center of Smith chart. And here if we will go 1.2, 1.4, 1.6, 1.8, 2, and directly 3. This is, you can say, semi-log paper if you are seeing. So it is related to that. It is similar to that. So it is 3, then 4, distance is reducing, then 5, then directly it will come to 10, directly it will come to 20, then it is 50, and at this extreme end it is infinity. Okay, so it is like similar to your semi-log paper. The first half from 0 to 1 it is there, and from 1 to infinity on this side. So this is semi-log paper. Now we can see what is this values. These values are the real part, that is the resistance. So if you want to locate a resistance of value zero point 0.1, so you will locate here. Zero point 0.2 here on this line, zero point 0.3 on this line. So what is the real part in the problem? So whatever the problem given, here the real part is 2. So we can locate the real part as 2. Where is the 2? So on this real part, this is 1, 1.2, 1.4, then 2. So 2 is here. So you can locate 2 here on this. So this is the real part. Okay. Now this real part, this small dot, this is the real part. But we don't have simply the real part. If you have to plot a impedance of only 2 and the imaginary part is 0, then this is correct. But if you want to plot impedance of with having some imaginary part, as imaginary part 1 is here, so you have to go on this imaginary lines. So on this circle, so whatever these lines, as you see, these lines, these lines, these lines, so these lines are mentioned here. So this is what here, zero point 0.1, this is zero point 0.2, this is zero point 0.4, zero point 0.6, zero point 0.8, 1. Now this may not be, this is only here. So if where you can see here, here the imaginary part here is 0, imaginary part here is zero point 0.1. So all the values on this line with having the imaginary part j equals to zero point 0.1, all the values on this line is having here, what is written, zero point 0.2. It is inversely written, the opposite way it is a zero point 0.2, all the values as having zero point 0.2, all this value here it is zero point 0.3, then zero point 0.4, then zero point 0.5, then zero point 0.6, then zero point 0.7, zero point 0.8, zero point 0.9, and 1. So 1 is at the y-axis, that is the cent here, vertical. Then 1.2, 1.4, 1.6, 1.8, here is 2, then 3, then 4, then 5, then here 10, then 20, then 50. So this way, the inner values on this, these are the imaginary values. So similarly, it is at the top on the upper half circle, and similar same values on the lower circle. So this is point 0.1, point 0.2, point 0.3, point 0.4, point 0.5, point 0.6, point 0.7, point 0.8, point 0.9, 1, 1.2, 1.4, 1.6, 1.8, 2, then 3, then 4, then 5, then 10, 20, 50. So this is on the lower side. Now what is the difference? The similar values are on upper side and lower side. So if your j imaginary part is negative, here it is positive, so it will be on the upper half of this horizontal line, and if it is negative it will be on the lower half of this horizontal line. So what is the imaginary part? Now imaginary part, you can say here, imaginary part is 1. So you just move on this line. So where is 1? So here you can see, here it is point 0.2, point 0.3, point 0.4, point 0.5, point 0.6, point 0.7, point 0.8, point 0.9, 1. Why we are going on the upper part? Because this upper part, this is plus. So on point 0.1 you come
Yes,
down.
it is plus.
Yeah, yes. So on this point 0.1 you come down. Point 0.1 I am coming down. So this is what my point 0.1 line. This is point 0.1 line, I am coming down. What is my real part? Real part is 2.
Yeah, it is
So
2, so
where
it will
it,
join there.
so where it intersect here. So
Yes, here.
this will be your point. So this will be your point where it intersect. So this point, so that is I am starting from 2. This 2 is my real part, and this 1 again it is written here, or you can see here 1. So this line is coming down. So this is my imaginary part. Okay, so this is what your impedance, this impedance, what I'll say, this is what my z1, z1, this impedance, whatever this I have calculated, I have plotted, this is z1, this is my impedance. Now if once impedance is plot, then we can do some processing and the other calculation. So that is the latter part, but very first that we have to clear the understanding of the impedance. Now I'll take some another example. Suppose I'll take the impedance. Now I'm not going for divide by Z0. I'll take directly the normalized value. So this is Z2 and the normalized value I am taking Z2 normalized. So can you suggest any value which we will plot?
8 plus 5j.
8 plus 5j. So before going for the higher value, we'll go for some lower value. I'll take it afterwards. So what I'll go for the lower value, I'll go for zero point 0.2 minus j uh, 0.4. Okay, so this
Okay.
minus one value also will take. Now you
Sir,
can go
in the Smith chart, we plot only the load impedance or source also we plot.
any impedance, whatever it is,
Achha.
up to you whether you called it as load impedance or source impedance or any. So that's why I name this as z1 z2. So any impedance you can say.
So first you need to convert it into normalize and then plot it,
Yes,
correct?
that's it. So it is any impedance, whether it is source or load or whatever it is, then you can plot. So I'll also
And Z0 is characterized impedance.
characteristics impedance.
Okay.
So this is what the characteristics impedance. Now this is Z2 we have to plot. Now what is the real part? Real part is zero point 0.2. So here it is zero point 0.2. So I will have to locate it is zero point 0.2. So it is here. So small circle, small dot, I'll just consider here at zero point 0.2. Okay, so this is zero point 0.2. Then as it is minus zero point 0.4, so I have to go down. So zero point 0.4. So it is zero point 0.1, zero point 0.2, zero point 0.3, and zero point 0.4. So zero point 0.4 line I have to come here where it is intersecting to the zero point 0.2 here. So this is zero point 0.2 line intersecting with the zero point 0.4, and this is what your intersection. This point is nothing but your Z2, Z2. Okay, so this is what your Z2. Now we will go to your impedance. Uh, so you just tell me your impedance value as you take. So this is I'll take Z3. I'll take the another color. Black is not visible. Mm, this color I'll take. Okay, Z3. You can say normalize. Z3 normal. Now you tell me your value.
5 plus 20j.
5 plus 20j. Okay. 5 plus 20, 10j ले लेते हैं. Okay.
ठीक है.
So it will be visible. Otherwise, 20j is also possible. 5 plus 20j. It is the normalized value. Z3. Okay. Now you have to go 5. So on this horizontal line, where is 1, 2, 3, 4, 5. So 5 is here. So here is your point and 10j. So 10j plus hai, so it will be on the upper part, and 10j you can say this is 1, 1.2, 1.4, 1, 2, then this is 3, then this is 4, then this is 5, and directly it is 10 here. So 10 here. So what is your 5 plus 10j? So where is 5? This is 5 real part. So 5 is going here, 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 and this is 10j. So it is intersecting. So here 5, this is 5 circle, and this is 10 circle imaginary. So 5 plus 10j, this is what your point. Okay, and this is what your Z3. Okay. So this is what your Z3, this point. Okay, understood.
Yes, sir, understood.
Now only we will go for the uh, another part. So here Z4 normalize.
So for the very
So
first one, Z1, there were two dots, right? The one that you drew
no, no,
on
no.
top.
That is I have put for the reference that
So do we
initially
have to join those two, or
no,
we have to just
no,
highlight it?
no, no. We don't need to join it. We have to. This is Z1 only one point. This dot I have put for the reference only because initially this is what the first case and on this complete line and it is very easy difficult to
So we have
focus
to. Okay,
that only for the reference I put it. So there is no need of
okay.
this dot, there is no significance
So
of this
we
dot. Only this
okay.
Z1 here.
So we have to mark Z where the two lines are intersecting. Is it
Yes, only one point.
okay?
Okay, now I have to this J0 plus point 2 j 0 plus 0 plus j point 2. This is what the impedance. Real part is 0. Now you tell me how to plot this. Z4.
So we will start from horizontal,
So very
left
first
horizontal, that is
horizontal.
zero.
Where is the 0? 0 is here.
It's left, extreme
Left hand.
left. Yes,
Extreme left hand side. Here is the 0.
it is point two, so it will go on top.
Point 1 and point 2. So here is the so here it is 0. So on this circle we will go up. So point 1 and this is point 2. So here is the point 2. So this is j plus point 2. Okay. So this is j. Here it will be exactly. So this is Z4. This is Z4. This point is Z4. Okay. We'll take some another that is Z5 normalize equal to point 0.5 plus J0. 0.5 plus J0. Then, so it is not,
So point five will
it
be
is simply the
somewhere
register.
in the
So register will be on the
yes, here,
horizontal
the
line. So
horizontal line.
here
Yes,
point
there.
0.5. Okay. And J0, where is J0? J0 is here.
It is horizontal only.
Ah, so what you can say here, here simply zero point 0.5, this is zero point 0.5, J0 is the horizontal line, so zero point 0.5 is here. So here itself it is, okay, so this is your Z5. So this impedance, it is Z5. Are you getting this? This is Z5. Okay. Now another impedance will go. Z6 normalize equals to 0.
Sir, in the previous example, the imaginary part is zero and the real part is point 0.5. So where do we have to mark the Z? Is it on the real part or imaginary part?
Real part, the Z5, here I am marked, na? Z5 is with the red dot on the horizontal line. Here only real part is there. So any real value will be on the horizontal line. So it is zero point 0.5. Here I have marked the Z5. Is it visible?
Yes. So if
Huh?
real is zero and imaginary is some number, then the marking will be on that imaginary number.
So that's now I'll come. Now the previously we did this. The real part is 0 and imaginary part is there. So we have gone on this outermost circle because Real part, where is 0? Real part is 0 here, and we are going on this circle, that is point 2, because real imaginary part is point 2. So we are going on this circle. So I'll go for, is it clear?
Yes, sir.
Okay. Now we will go for the next, that is z6 equals to 0. Both the part will be 0. Now tell me where the look, where it will locate.
The left extreme 0.
Yes, left extreme 0. So here it will be. So this is what the part point, and this is z6. So this is z6, z6. And if I'll put z6 equals to infinity, z7 equals to infinity, then
Extreme right.
extreme right, correct. So it will be at the extreme right. So I hope we have covered all the possibilities in this case. If you want to share anything, then let me know. Any other impedance, otherwise we'll stop this.
Sir, minus 4 plus 6. Minus
Okay.
4 plus 6j.
Okay, so we will go for the next, that is Z7 normalize. Z7 normalize equals to minus.
4 plus 6j.
Now here minus 4 is not possible. Minus 4 is the resistance value. So negative
Okay,
resistance,
so
physically it is not possible. So 4 is
okay,
possible. So in the resistance, minus 4 you cannot locate, because in
okay,
the reactance due to inductor is the positive reactance due to capacitor is the negative reactance. So there is no real part. This is the register part, that may be that may be 4 only, or whatever the real value, or the integer value, sorry, or it will be the real value, 4.4, 0.1, whatever it is. And so it will not be the negative. Okay, 4, then
4 plus 6j.
4 plus. Okay, we'll take minus, so that we had not taken much example of the minus. Is it okay?
Okay, sir.
4 minus.
6j.
Okay, J6. 4 minus 6j. Now you tell me where we can locate it. Where is 4 on the horizontal line? Here is 4.
Yes.
Okay, so this circle will go down. And 6j. So this is 1,
6
this
is
is,
not there. It is between 5
ah,
and
so this is 3, 4, 5, and 10. So it is 5 and 10. So this is 6, this is 7, this is 8, this is 9, and this is 10. So this is 6, this line. So 4.
okay,
So where is it will go here? Where is the 4 line? 4 it will come, 4 it will come down. So this is the thick line is 5, and this is 6. So where I have to mark? So this is 4, it will come down. This is 5, and this is 6. So 4 minus 6j here.
yes,
This will be the dot. Okay. And this will be the here Z7. So this is what your Z7 here. Is it okay? Or anything else you
yes.
want to plot?
Okay, sir. Understood.
Okay.